In today's lecture, we are going to study band formation in solids. How the energy bands can be formed in solids that we have to cover in this lecture. Now, according to quantum mechanics, electrons can be present in different energy levels. So, for electrons, there are certain allowed discrete energy levels. Electrons cannot be present in any level, but only in a certain discrete energy levels. And again, Pauli's exclusion principle stated that each electron requires a separate energy states. No two electrons can occupy the same energy states. That is Pauli's exclusion principle. And that's why if we take an example of a hydrogen atom here, you can see hydrogen atom which contains one proton inside the nucleus while one electron is revolving around the nucleus. As there is only one electron and therefore it requires only one energy state. So I have written here one energy state is required for this one electron. Now, if we consider another hydrogen atom, then again electron is revolving around the nucleus, only one electron, and that's why it requires only one energy state, which is shown here. Now, if these atoms are at a longer distance, here I have taken distance between two atoms, small r, and if small r is large, distance between two atoms is large, then interaction between two atoms will be very, very small. And as interaction is very, very small, therefore what will happen? There is no splitting of the energy level, no interaction, so no changes in energy levels. But if the distance between two hydrogen atoms goes on decreasing, here you can see if we go on decreasing the distance between two atoms, then interaction between the orbits will increases. So there will be more and more interaction. And now if this is the situation when distance between two atoms is very, very small, very, very small means here we have considered that two orbits overlap with each other. If there is a overlapping of the orbits, then you can see one electron from first hydrogen atom may become a part of the second, while electron from the second atom may become a part of the first atom. And as we know, Pauli's exclusion principle suggested that each electron requires a separate energy state, and that's why now for this atom there may be electron of its own or from the neighboring atom, and therefore it requires two energy states, and that's why this single energy state is now split into two energy states. Similarly, in case of atom 2, there may be a possibility of two electrons. Two electrons means one electron will be present at a time, but it may have its own electron or electron from the neighboring atom, and that's why again second atom also requires a two energy states, and single energy state will be split into two energy states. This is only because of the interaction between the orbits. As distance goes on decreasing, interaction will go on increasing, and because of this interaction, energy levels will be splitted. Now, as we know, solid consists of billions of atoms. Alright, billions of atoms are present in a very small volume, and that's why there is a strong interaction between these billions of atoms, and hence single energy level will be splitted into billions of energy levels. These energy levels are closely packed, and these energy levels appear to be continuous in that region, and that region of closely packed energy levels is called as the energy band. Again, let me take one example how the band formation takes place. Consider an example of silicon atom. Silicon, whose atomic number is 14, and therefore electronic configuration is 284. Now here it can be shown like this: 1s2. So first orbit, that is K shell, and its subshell is S. It contains 2 electrons. Second orbit, it has 2 suborbits or orbitals, that is S and P. So S will contain 2 and P will contain 6. So total second orbit contains 8 electrons. And third orbit, its S orbital contains 2 and P orbital contains 2. So third orbit or shell, it contains 4 electrons. So this is electronic configuration of a silicon. Now we can show these energy levels like this. You can see the energy levels which are, this is for first orbit, that is 1s2, 2s2, 2p6, 3s2 and 3p2, like this. So these are the different energy levels. So you can see this is a graph between interatomic distance, that is distance between two successive atoms, which is denoted by small r and plotted along x-axis, while energy is plotted along y-axis. Here you can see when a distance between the atoms is larger, atoms are at a longer distance, then these energy levels are separate, and for each atom it has a separate energy levels. There is no splitting, no interaction. So distance is denoted by A, B, C, D and so on. Now if distance is very large, much greater than D, then energy levels are separate. It means there is no interaction. Here number of electrons are also shown. You can see 1s orbital contains 2 electrons, 2s contains 2, 2p contains 6, 3s contains 2, 3p contains again 2 electrons. Now distance is longer, more, then the splitting will not be there, means interaction between the atoms will be very, very small. So here interaction is small, so no splitting. Now up to point D, when interatomic distance is distance OD, then you can see for this line energy levels are separate. There is no splitting, means no interaction. Now go on decreasing the distance between the atoms. If we again decrease the distance between atoms up to point C, so between point D and C there is no splitting, means no interaction. Again energy levels are separate. Now again go on decreasing the distance between the atoms below C, then interaction will start. Now interaction between the atoms will start, and because of this interaction, splitting of the energy levels will take place. So here splitting of the energy level will start. Now you can see as the distance again decreases, splitting will increases, because interaction increases and splitting will be more and more. Now the splitting of these inner energy levels we will discuss later on. For us important is 3s2 and 3p2. Now 3s orbital, its capacity is of 2 electrons only, and if there are n number of atoms present, then total number of energy state will be 2n, because single energy level will be splitted into 2n energy levels, and that's why total number of energy states will be 2n. Now corresponding to 3p, p orbital can contain 6 electrons, and if there are n number of atoms, interaction is between n number of atoms, then it requires 6 n states. So 3p orbital will have 6 n energy states, while 3s will have 2 n energy states. And because of the interaction, now splitting starts. You can see from point C to B, as the distance decreases, splitting of the orbital goes on increasing. Sorry, splitting of the energy levels increases. So energy levels will be split. Now, as soon as we reach at a point B, now you can see corresponding to distance B, here because of the splitting, these two energy levels are mixed together, and therefore 2n states of 3s orbital and 6n state of 3p orbitals will combine together, and there will be, in this region, there will be total 8n states. 8n states are available at a point B. Now, again go on decreasing the distance between the atoms, then splitting of the shells will be like this. Splitting of shell will take like this, and at a point A, you can see at a point A, the structure will be like this. So again that combined band is split into two bands. Here this is one and this is another band. And during this splitting, energy states will also be splitted. Here this lower band contains 4n energy states, while upper band contains 4n energy states, out of which 4n occupied states are present in a lower band and 4n empty states are present in a upper energy band or in a upper region. Now, A is suppose a lattice constant. Lattice constant means it is a distance at which crystal is formed, because crystal is formed at a particular distance only, not less than it or not more than it, otherwise it will not be stable. Suppose A is the lattice constant where crystal will be formed. It means the structure, band structure will be like this. Means there is a lower band which contains 4n states, and all these states are occupied by the electron, means all these states are filled. And corresponding to this one, we get a one energy band which contains how many? 4n number of different energy states. Single energy level is splitted. This single energy level is splitted into 4n different energy states. And that energy states is called as bunch or group of energy states is called as the band, and that lower band is called as the valence band. Why? Because of this upper energy level, due to splitting of upper energy level, we get another band which contains 4n energy states and which are empty. So from these 4n empty states we get another band, and that band is called as the conduction band. While these two bands are separated by a gap of energy, and that gap of energy between these two bands is called as the energy gap. So in this way we get valence band which contains valence electrons, and we get upper band which is a conduction band which contains conduction electrons. In this case, valence band is completely occupied and conduction band is completely empty. Now, what about these inner bands? Splitting of inner bands, that is 1s, 2s, 2p also takes place, but you can see that splitting is very small. Why splitting is small? Because these inner bands or inner orbits are shielded by the outer orbits, and that's why interaction will be maximum for the outermost orbit, and inner orbits are shielded or protected by the outer orbit, and that's why for inner orbits interaction is very small. As interaction is very small, means splitting of the orbits or energy levels will be very small. So what will be the energy bands formed due to inner orbits or inner shell, that is called as a core band. And in electrical conduction, when we study the electrical conduction in solids, then these bands are not of importance. They have less importance. Less means actually no importance. The bands which are important for us are valence band and conduction band, and that's why these core bands are neglected. So in this way, the band formation in a solids takes place. We have seen how the band formation takes place. Quantum mechanics is responsible, and especially Pauli's exclusion principle. Finally, we can draw the diagram, band diagram in a solids, because only two bands are important for us, and that's why I have drawn these two bands. Lower band is called as the valence band. Its energy is denoted by EV. Upper band is the conduction band, and its energy is denoted by EC. Now, what is meant by valence band? The energy band which contains valence electrons. The energy band which contains valence electron is called as the valence band. It is never empty. It is either partially filled or it is completely filled, but it is never empty. It always contains some electrons, which are the which are the valence electrons, and they are bounded. They are not free for the electrical conduction. So all the valence electrons are bounded, and that's why they cannot play role in the process of electrical conduction. While conduction band, the band just above the valence band is called as the conduction band, or the band which contains conduction electrons or free electrons is called as the conduction band. When electrons are present in a conduction band, then only electrical conduction is possible. If conduction band is empty, then electrical conduction is not possible. Again, there is a gap of energy. There is a gap of energy between valence band and conduction band, and that gap of energy between valence band and conduction band is called as the energy gap. We can also define it as the difference of energy between top of the valence band and bottom of the conduction band is called as the Eg, and here we can write Eg is equal to Ec minus Ev. Difference between the energy of conduction band and valence band is the energy gap, and its unit is electron volt. That energy gap is small, and that's why it is generally measured in terms of electron volt. It is also called as a forbidden gap. This energy gap is also called as a forbidden gap because this band, this region between conduction and valence band is not allowed for the electron. Not allowed for the electron means that region is forbidden. Region is forbidden for the presence of electrons, and that's why this band is also called as a forbidden band or forbidden gap. Alright, band gap, forbidden energy gap or energy gap. So this is a definition of valence band, conduction band and energy gap. And depending on this energy gap, whether it is small, whether it is large or moderate, solids are classified in three classes, that is conductor, semiconductor and insulator. So this is a concept of band formation in a solids. So thank you.